up, guys? This is Joe from Lombardi Engineering, and today we're going to be talking about a project of mine. It's a 1/16 scale mouse, and I'm trying to make it an RC tank. Here is the rough draft of it so far. What I'm trying to do is make it how the original engineers would have designed it. So all of the parts for the turret that would have been plates are individually printed and then pinned together like they have on the actual mouse. I've got a picture right here. So pins driven in. I've also got the side skirts here. They're a pain. And so each individual one of these vents will be removable. Right now they're installed with a couple of, like, I don't know, 0000120 screws, so very tiny. But eventually the turret is going to be able to rotate, tracks move on its own. Every hatch is going to be able to open. It just pops off. But it's a very exciting project. I love the mouse. The mouse is my favorite tank ever. I've been to see it in Moscow. I'll probably put a picture in right now. It's huge in real life, and 1/16 scale doesn't do it justice right now. So this first video is going to be of the assembly of parts of the drivetrain, which has been kind of an interesting engineering experiment for me, because I wanted to put it all together, as I said before, as close to the original as possible. So I'm not going to have all of the gear reductions. I know the mouse had a two-stage gearbox. I'm just going to have an electric motor, and it's going to be a chain drive. I've got number 25 chain. Right here. This will be going around a drive gear here, and then ending up on this end of the drive shaft, which will in turn spin the drive gear. I've got a little printout of what the mechanism looks like by itself. You can see that the original mouse had these sprockets on the outside attached to these two sort of like half circle, I don't know how to call them, like sprocket receptors, sprocket containers, sprocket bases, which in turn were coupled to the drive shaft. And so to do that, I just have some 1/4 bolts going through this main drive shaft, which is 1/2 inch, and then on either side I have the housings, which on the outside is a needle bearing, and on the inside is a 2-stage just radial bearing, as well as including in this diagram thrust washers and a spacer, so that it is bound axially and radially. Ugh. Snapping this all together. A lot of the parts are way too big to print on just like any standard printer, so a lot of them have a seam in the middle where I install 3/16 inch pins. Basically, this is, I think, nylon rod, and they just snap together. This 3/16 inch pins are the exact same size that are scale at 1/16 to the pins that they drive in for the larger plates, like the side skirts, the turret plates, and so on. I'll move this out of the way, and we'll look at this right here, which is the most recent iteration of the rear side skirt and the back. So the difference between the two versions that I have, this one's actually got all the holes needed to mount the bearing holder, bearing box, bearing cylinder onto the main body here. Same with the side skirt, which has the two access ports, one for the motor and the other one for the drivetrain. The drivetrain one is a little bit oversized, so I can fit, in true fashion, I can fit the equipment straight through, which is how the mouse was probably actually designed, because once they put all of these plates together and weld them, there's no separating all of the various components of that. It's just a very tight piece of equipment. This is the, I don't know, the bulkhead between the turret area, the turret compartment, where they have like the ammunition as well as the main generator stored. And this is exactly where they would have put the electric motors, in here. And so the electric motors had a clutch system that drove down through gears down to the main drivetrain. In my version, it's going to be all electric as opposed to a diesel electric vehicle. Someday that would be awesome to make, but that would have to be done in something like 1/5 or 1/4 scale. So let's install these motors. Alright, so I've got the gearboxes as well as the motors installed because they're a single unit. They're attached to the rear bulkhead, and overall I'm pretty happy with the fit up. I'm going to just test for the fact that they actually still move. I was a little concerned about the height from here not matching up the height from here, which holds the top plates on. But after working around, I was able to find out the correct height for them. Alright, and as you can see, maybe, it's turning up in there, which is fantastic. So I've got it made so that at roughly 12 volts, it's moving at scale speed. So hopefully I'll be able to have enough low-end torque to do slow speed maneuverability and still be able to make it to maximum speed, scale speed. Next step, I'll be installing the inner bearings on the main hull, and I'll be installing the outer bearings on the side skirt. Let's get to it. Okay, so now I've got the inner bearing installed, as well as the outer bearing. We're going to talk about the drive shaft real quick. So here we've got the actual metal drive shaft, right? Through there, we've got the 2 1/4-20 bolts that are in these 2 clamping plates that go on to the sprocket housing, which have the actual drive sprockets on the outside clamped to them. To do the thrust washers, we've got thrust washers themselves. I should say thrust bearings. Then these needle bearings that are radial needle bearings with another washer, and then finally a spacer. And then same goes for the other side as well. Ideally, what happened for installation would be having the mouse made, and then you take off the inspection cover here. You insert your drive shaft all the way through. Then once it's through, you can see we've got the area for mounting the 1/4-20 bolts. You'd start installing all of the pieces, particularly you'd put the drive sprockets on the sides before putting the shaft. Then you put on the 2 hemispheres and you'd clamp down on them and then reinstall the sprockets on the sides using the holes. And then you can wrap the chain, the track around, and it's done. But because I've already got the drive gear all built, instead I'm just gonna put it together because that's super easy. I love it when a plan comes together. So that looks fairly decent. I can put on the back plate from the previous mouse model on there. And then I can also insert the drive mechanism like so. And it's already starting to look a ton more like the actual mouse. Here, I've got some track already built up. I'll probably have another video. And that looks like the butt of a tank. This is great. So wiring is going to be kind of goofy since we've got such a small amount of room in here, but I've got access around the back as well as 2 holes that I installed in the fronts. I've also got another file for this back bulkhead that is unchanged, as in it's exactly how it would have been on the real mouse, without these mounting holes for these specific motors and without some of the reinforcements I've done to hold the motors here, because in the actual mouse they had different bracket systems to hold it together. Overall though, very satisfied with the small amount of progress made today. Thank you for tuning in. This is Lombardi Engineering. I think this will be either video 1 or 2 in a multi-part series from start to finish of the making of the mouse 2. Alright, thank you.